Hey guys, we're solving this physics paper today. This is my first video from the February-March 2023 series. This is 9702, paper 22, February-March 2023. The paper isn't out yet officially. I got it from Reddit. So we don't have access to the grade thresholds yet. You'll get access by May, I'm guessing May. But we do have access to the pre-standardized mark scheme. I'm going to link the question paper and mark scheme in the description. So let's begin. Also, I plan to do chemistry paper 2, physics and chemistry paper 4 and 5 following this video. Paper 1 isn't out yet. You'll get that before your exam in the May-June series. It's going to be out in May, and I guess your paper 1 exam is in June, right? So I'm going to solve that in May when it comes out. Okay, let's begin. Starting with question number 1. So this is your formula sheet. This was updated back in 2022. Underline all the SI base units in the following list. We know that there are 7 SI base units. So ampere, it is a SI base unit. It's the unit for current. Coulomb is not a SI base unit. Current is a base quantity, not a base unit. Kelvin is the base unit of temperature. And Newton is not a base unit, it's a derived unit. A toy car moves in a horizontal straight line. The displacement s of the car is given by this equation. S equals to v squared by 2a, where a is the acceleration of the car and v is its final velocity. State 2 conditions that apply to the motion of the car in order for the above equation to be valid. Alright, as you can see, this is a variation from the original formula that we know of. What comes to mind after seeing this equation? This is the first equation that comes to my mind. V squared is equal to u squared plus 2s. Alright, so for this equation to be valid, see that there's no u here, right? So what could it be? Since u is absent, u is definitely 0, so we end up with v squared is equal to 2as, followed by s is equal to v squared divided by 2a. So what are the two conditions for this to be valid? We have to say that the initial speed or velocity is 0, and motion has to be in a straight line, or you could say that acceleration is constant. Basically, they accepted motion is in a straight line in the previous mark schemes, but in the current mark scheme, I only see magnitude of acceleration is constant. They wrote that ignore straight line velocity, as straight line is given in the question. Okay, that is why you can't mention that, as it's already mentioned here. Okay, so the first point is initial speed or velocity is 0, and we have to say that the magnitude of acceleration is constant or uniform. Fine, let's move on. An experiment is performed to determine the acceleration of the car in B. The following measurements are obtained. Alright, let's calculate acceleration. So A is equal to v squared divided by 2s, or A is equal to 3.89, sorry, 2.75 square divided by 2 times 3.89. As you can see, our data is given to 3 significant figures, right? So we should opt for a 3SF answer. 2.75 square by 2 into 3.89. So we're getting an answer of 0.972. In the mark scheme, they use 0.97 and they wrote in the guidance part, allow 2 significant figures or more SF. Basically, it should be 3SF since the data is given to 3SF. Now determine the percentage uncertainty to 2SF in A. Fine, so the percentage uncertainty is basically V is squared, right? So we have to consider V twice. It's basically V times V. So the percentage uncertainty of V is 0.8. So that's 2 times 0.8%. If it was cube, we'd consider it 3 times, 3 into 0.8. But since it's square, we do 2 into 0.8 and followed by added by 0.5% for S. That gives us a value of 2 times 0.8 is 1.6 plus 0.5 is 2.1% to two significant figures. Okay, and I'm ignoring 2 since 2 is a constant, it has no uncertainty. Use your answers in C1 and C2 to determine the absolute uncertainty in the calculated value of A. Fine. So we know that the percentage uncertainty of A is equal to del A by A times 100. So del A by A is basically equal to 2.1 divided by 100. Therefore, del A is equal to 2.1 by 100 times the value of A that we just found out, 0.972. So it's wise if you use the exact calculated answer. So I'm going to do it again, 2.75 whole square by 2 times 3.89. So that answer multiplied by 2.1 by 100. That gives you a value of 0.02. So absolute uncertainty, remember, absolute uncertainty is always given to one significant figure, okay? So that's 0.02 meter per second square. Moving on to question number 2. A motor uses a wire to raise a block as illustrated in figure 2.1. The base of the block takes a time of 0.49 seconds to move vertically upwards from level x to y at a constant speed of 0.64. So there's no change in kinetic energy in the first part. During this time, the wire has a strain of 0.0012. The wire is made of metal of Young modulus 2.2 into 10 to the power 11 pascals and has a uniform cross section. Okay. The block has weight of 1.4 into 10 to the power 4 newtons. Assume that the weight of the wire is negligible. Calculate the cross section area. So since Young modulus is given, we know that Young modulus is equal to stress by strain. So Young modulus is equal to stress sigma by strain epsilon. Now we know that basically we have the strain given, right? So Young modulus is equal to stress, which is force by area divided by strain. So from here we can write E is equal to F divided by A epsilon. Now let's just make A the subject. We end up with force divided by Young modulus times epsilon. So what do we end up with? What is the force? It's weight 1.4 into 10 to the power 4. What is the Young modulus? It's 2.2 into 10 to the power 11 times epsilon, which is 0.0012. Fine, let's do this. 1.4 times 10 to the power 4 divided by 2.2 into 10 to the power 11 times 0.0012. That gives us a value of 2SF. A is equal to 5.3 into 10 to the power minus 5 meters square. Okay, that's the answer. Now, the increase in the gravitational potential energy of the block for the movement of its base, okay, from x to y. So what's the distance x to y? We don't know that, but we do know the speed and time taken. So basically, we know that for constant speed, s is equal to vt. So h is equal to 0.49 times 0.64. That's the distance moved or the height obtained. Now we know that change in energy, or basically GPE. The change in energy or GPE is basically mg del h. So what's the mass? Oh, we have the weight, right? That's 1.4 into 10 power 4 times the change in height, which is 0.64 times 0.49. So 0.64 times 0.49 times 1.4 into 10 power 4. That gives us a value of 4390.4. Now, since our data is given to 2SF, I'm going to round it off to 4,400 joules. All right, or 4.4 into 10 power 3. That's what they wrote. Same thing. Moving on. The motor has an efficiency of 56%. Calculate the input power to the motor as the base of the block moves from x to y. Okay, so efficiency is basically useful output power divided by total input power into 100%. So what's the total output power? It's basically this gain in GP, because our speed doesn't change as we're moving at constant speed, right? So we just have to find out the total input. So we know that efficiency is output by input into 100%. So you have multiple ways to do this actually. You could also do this using P is equal to FV. That's also fine since you're moving at constant speed. So this is one way of doing this. Check this. So efficiency is equal to output power by input power into 100%. So 56%, right? 56 by 100 is equal to, what's the output power? It's 4400 divided by the input power. So if we solve this, we get a value of input power is equal to sorry 4.4 into 100, right? Yeah. Oh wait, this was the energy in joules, right? So basically I have to convert this value to joules, I mean to watts basically, because it's in joules. So let's do that on the side over here. We know that P is equal to FV. So P is equal to this is one way of doing it. I'm going to show you two ways. Okay, I'm going to show you two ways. Basically the first one is using the basic formula of power is equal to work done by time. So if I do use this, I can find out the output power. How? The work done is 4.4 times 10 to the power 3, while the time taken is 0.49 seconds. Okay. So if I solve this, I get an answer of 4.4 into 10 to the power 3 divided by 0.49. 8979 or 8980. You can round it off to 9 into 10 to the power 3. Okay. And if you use your accurate answer from this part over here, if I used 1.4 to 10 power 4 times 0.64 times 0.49, if I used 4390.4 divided by 0.49, I'd get a value of 8960 basically. Okay, so you don't need to show that, it's fine. Basically you can write 8960. Now it's rounded off to, if you write it to two significant figures, it's 9000 watts. Okay, so we are meant to do this beforehand. This part comes later on in the question. So yeah, we can do this first, followed by this red part over here. So it's basically 9 into 10 to the power 3, right? Now input power is equal to 9 into 10 to the power 3 times 100 by 56. Okay, let's do this. So to two significant figures, we get an exact value of 16,000. If you use your exact answer, if you carry forward the exact answer, you will get an answer of 16,000 watts. So that's 1.6 times 10 to the power 4 watts. Okay. So this is one approach. The other approach is you can directly find out the output power using P is equal to FV. You know that the weight that you're working against is the force. So that's 1.4 times 10 to the power 4 weight, and the velocity is, what was it again? 0.64, right? So if you do that, 1.4 times 10 to the power 4 times 0.64, that gives you a value of 8960 or 9000 watts. So that is your input power. So two ways of finding out the input power followed by efficiency. Now, the base of the block now has uniform deceleration of magnitude 1.3 meter per second square from level Y until the base of the block stops at level Z. Calculate the tension in the wire as the base of the block moves from Y to Z. Okay, so we've reached Y. Now we're moving from Y to Z. However, the base of the block now has deceleration until the block stops, so our final speed is 0. Calculate the tension in the wire as the base of the block moves from Y to Z. Okay, so here the resultant force is downwards. We know that the upward force is tension and the downward force is weight, basically. right? The upward force is tension and the downward force is weight. So you can do it in many ways. Since we are decelerating, right? Since we are decelerating, that means that the downward force is greater since we're decelerating, right? This is the object, this is tension, and this is weight. And we are moving up, but we are decelerating. So what does that mean? Weight is higher, okay? So we can write that weight minus tension is equal to ma. So the weight is fixed at 1.4 times 10 to the power 4 minus tension is equal to, what's the mass? We need to find that out. We know that W is equal to mg, so m is equal to W by g, which is 1.4 times 10 to the power 4 divided by 9.81 times the acceleration or the deceleration of 1.3 meter per second square. So if you solve this, you get 1.4 times 10 to the power 4 by 9.81 times 1.3, then 1.4 into 10 to the power 4 minus answer. So you're getting an answer of t is equal to two significant figures, 12,000, or 1.2 times 10 to the power 4 newtons. Awesome. You could also make t the subject. If you made t the subject, it would have been like this: t minus w is equal to m times minus 1.3, since you'll be decelerating and you've considered the upward direction to be positive. You'd get the same answer, guys. Next, the base of the block is at levels x, y, and z at times tx, ty, and tz respectively. Okay, on figure 2.2, sketch a graph to show the variation with time of the distance d of the base of the block from level x. Numerical values are not required. So basically, guys, you know that the gradient of the distance time graph is basically speed. Now, you're moving at constant speed from tx to 2y. What does that mean? That you will have constant gradient from tx to ty. And then you start decelerating until you reach a velocity of 0. Guys, you know that when you reach a velocity of 0, the gradient of the graph becomes horizontal or 0, right? The graph becomes flat, which indicates a gradient of 0. So essentially, what will our graph look like? From tx to ty, it should be a straight line with positive gradient, and then the gradient will slowly decrease until it reaches 0 at tz. Okay, so numerical values are not required. So for example, I can just do this. Why don't I do this? Check this. So I can just draw a straight line from this section to here. Wait, let me just draw a shape. So this is the first part, straight line. Use your scale to draw this, by the way. Now what happens after this? After this point, we start decelerating, right? So it will be a curve now, and it will eventually become horizontal at z. Okay, it will eventually become horizontal at z. So the graph should look like this, something like this. Here you go. So hard to draw graphs like this. Okay, so this is how you score 2 marks. Straight line section here with positive gradient, followed by curve with decreasing gradient until it becomes horizontal or flat. Let's move on to question number 3. This is a question on moments. State 2 conditions for an object in equilibrium. I always ask this question to my students. So the first condition is the resultant force is 0, and the second point is resultant moment or torque is 0. Okay, so resultant force in any direction, this is optional, is 0. Also, the resultant torque, sorry, you could say resultant moment or torque. Basically, torque is resultant moment, is 0. These are the 2 conditions. You can say about any point, by the way, that's also optional. About any point. Okay, show that the vertical component of tension in the string is 30 newtons. So they're talking about this component over here. So that's going to be 17 sine 50, right? 17 sine 50. Remember that the force with the angle is cos theta, and the force that is not with the angle, right? That's sine theta because of trigonometry. So 17 sine 50. How much is that? 13. Great. By taking moments about NA, calculate the weight of the beam. Okay. So this is a uniform beam, so the weight should pass through the center. The total length of the beam is 0.35 plus 0.15, 0.5 meters. So the weight should pass through the midway point, which is 0.25 meter. So they told us to take moments about end A. This is our pivot. So what are the clockwise moments? Weight and the 12 Newton force, they're providing clockwise moments, and the vertical component of tension is providing an anti-clockwise moment. The horizontal component of tension is not providing a moment since the force passes through the pivot itself. Okay, so the sum of clockwise moment is equal to the sum of anti-clockwise moment. You guys can write that point if you want. So let's do this. So W times 0.25, that's our clockwise moment, right? This one. And this distance I just told you it's 0.25. The 12 Newton is also providing a clockwise moment. What should the distance be though? Basically, it's 0.15 meters from end B and 0.35 meters from end A. So it's going to be 0.35 times 12 newtons, and that's balanced by 17 sine 50, the vertical component, 13 newtons, right? Times the distance, which is 0.5 in total. Let's solve this. Data is given to 2SF, by the way. So 13 times 0.5 minus 0.35 times 12 divided by 0.25 gives me an answer of 9.2 exactly, 9.2. So W is equal to 9.2 newtons. Right, great. Now, calculate the magnitude of the vertical component of the force exerted on the beam by the hinge. So, how do we do this? There's also a vertical component of force exerted on the beam by the hinge. So, essentially, remember that the tension over here also has a component like this. Okay, so to balance things out, there must be a horizontal component is in this direction, and look at this, the net vertical force, how much is it? 9.2 plus 12, that's 21.2, and the vertical component is 13. The downward force is greater than the upward force, but since our object is in equilibrium, the net force must be 0. So there clearly must be an upward force acting on the beam from the hinge. Okay, so net upward force must be equal to net downward force. So can we write it like this? W plus 12 is equal to 13 plus the force that we're talking about. So 9.2 plus 12 minus 13 is equal to F. So F is equal to minus 1 plus minus 1 plus 9.2, which is 8.2. F is equal to 8.2 newtons. They wrote 8 in the mark scheme for some reason. But they wrote allow one or more significant figures provided that answer rounds to 8 to 1 SF. It's 8, guys. Now, the block is now moved closer to ND. Fine. So we essentially move the block closer to ND. Fine. So what happens to the magnitude of the clockwise moment? It actually decreases since we're moving closer to the pivot. Assume that the beam remains horizontal. State whether the change will increase, decrease, or have no effect on the horizontal component of the force exerted on the beam by the hinge. Remember I told you a second ago that there has to be a horizontal force that is exerted on the beam by the hinge that balances this horizontal force, right? So now this question is a bit critical. Let's try to understand. So basically, beforehand, what was it? The horizontal component was 17 cos 50, right? So 17 cos 50, that gives you a value of 10.9. This was also the value of this force, which was balancing it, the force on the beam by the hinge. Now what happened? We moved the object closer, right? We moved the weight, right? Specifically this weight, the block, basically we moved it closer to the hinge. As a result, it still has the same weight, 12, but the net clockwise moment decreases. For example, why don't I just give you guys an example? What if this length is now in total 0.3 rather than 0.35? Okay, so what's gonna happen? 12 times 0.3 plus 9.2 times 0.25 is the net clockwise moment. So that's 12 times 0.3 plus 9.2 into 0.25. That gives you an answer of 5.9 Newton meter. Okay, so the net clockwise moment that the tension, the vertical component of the tension has to balance is 5.9 Newton meters. But look at this statement. They mentioned here that the beam remains horizontal. This is so important. Assume that the beam remains horizontal. What does this indicate actually? It means that the beam will maintain its current position. That means, you know, this angle over here, which was at 50 degrees beforehand, it will remain at 50 degrees. If the angle changes, right, the beam will no longer remain horizontal, right? So the angle cannot change. So just think about this. If the angle doesn't change, right, how does this string still maintain equilibrium? Because at this higher value, the net anticlockwise moment must have been greater, right? So that leaves us to one possible option. The value of tension actually changes and it will actually decrease to balance things out. So check this. It's going to be equal to 5.9 is going to be equal to the tension sine 50 times 0.5 distance. Let's try solving this. 5.9 by 0.5 divided by sine 50. This gives you an answer of T is equal to 15.4 newtons. This is our new tension after the block has been moved closer to end A. Now think about it. What are the only two horizontal forces here? This horizontal component from the string and the horizontal force acting on the beam from the hinge. So to balance this force, it's not 17 cos 50 anymore. It turned into 15.4 cos 50. Let's try doing this. 15.4 cos 50. That gives you an answer of 9.89 or 9.90 Newton. As a result, since the horizontal component of the string has decreased from 10.9 to 9.9, this horizontal force acting on the beam from the hinge must also decrease to 9.90 to keep things in equilibrium. So that's the working. Okay, so our answer will be it decreases. So yeah, pretty complicated. So if you face these types of questions in the exam where an explanation isn't required, I just recommend doing this at the end. Just focus on the easier questions and then come back here later. Okay, you have to consider a specific scenario with new values followed by some working, okay, to figure things out. You also have to do this in electricity, by the way. Moving on to question number 4. This is a question on momentum. There are 7 questions in total in this paper. Two blocks slide directly towards each other along a frictionless horizontal surface as shown in figure 4.1. The blocks collide and then move as shown in figure 4.2. Block X initially moves to the right with a momentum of 0.37 kg meter per second. Block Y initially moves to the left with a momentum of 0.65 kg meter per second. After the blocks collide, block X moves to the left back along its original path with a momentum of 0.13. Block Y also moves to the left after collision. Block X has an initial kinetic energy of 0.30. Calculate the mass of block X. Okay, so we know that kinetic energy is equal to half mv square. So we can write that 0.30 is equal to half times, we know the momentum, right? We know that momentum is equal to P is equal to mv, right? Can we do this? Half into mv into v. We can do that. Or you can find out, you can basically do this substitution over here. Essentially there are multiple ways to do this, honestly. Like, check this. This is one way. So we know that P is equal to 0.37, right? So you can do this. 0.30 is equal to half times 0.37 times velocity. So v is equal to 0.30 times 2 divided by 0.37. 0.3 times 2 divided by 0.37. So that gives you a value of v is equal to 60 by 37, or 1.62. Now you know that P is equal to mv. So you can write m into 1.62 is equal to 0.37. So 0.37 by calculator answer gives you an answer of mass is equal to 0. To 2SF 0.23 kg. 0.23 kg. That's one way. What is the other way? You know that kinetic energy can be written like this. E is equal to half mv square and P is equal to mv, right? So E is equal to half m square v square by m according to rationalization. I multiplied m on both sides, so it's half P square by m. Now you can find out mass directly. So mass is equal to half times P square by E, which is half times 0.37 square by energy 0.30. That gives you a value of 0.23 directly. Okay, works. Determine the magnitude of the momentum of block Y after the collision. Okay, so momentum has to be conserved. You guys know that, right? So what's the initial momentum? Plus 0.37 minus 0.65, right? So plus 0.37 minus 0.65 is equal to, what's the net final momentum? Minus 0.13 plus final momentum of P. So they actually want the magnitude over here. That is why I'm going to apply the sign of Y. We know that after collision, block Y also moves to the left. That's why I'm just going to write minus P, because I want the magnitude only, right? So I'm applying the sign over here. So if you solve this, 0.37 minus 0.65 plus 0.13, that gives you minus 0.15 is equal to minus P. So P has a final value of 0.15. This is the magnitude of momentum, but it's a negative value. So if this just said momentum, you'd have to write minus 0.15. Okay, kg meter per second. Block X exerts a force on 7.7 during the collision. We know that force is defined as the rate of change of momentum. So F is equal to del P by del T. So let's find out the change in momentum of, basically you can do it either way. You can use any subject. But since block X exerted a force on Y, we can find out the change in momentum of Y. So it was 0.65 initially, and it turned into 0.15, right, at the end. So what's the change in momentum? So initially it was 0.65 and finally it became minus 0.15. So we can do it this way. 7.7 is equal to final momentum minus 0.15 minus the initial momentum, which was minus 0.65, divided by del T. So 7.7 is equal to minus 0.15 plus 0.65 divided by del T. And then del T gives you a value of 0.065 to 2SF. 0.0649, which is rounded off to 0.065 to two significant figures. Okay, see if that makes sense. You could also do it using X. It changed from plus 0.37 to minus 0.13. Check this. Plus 0.37 to minus 0.13, right? So if you consider this value to be positive, the net change is del P is equal to plus 0.13 minus what was the initial? 0.37. Okay, so that's 0.13 plus 0.37, which is del F is equal to del P by del T. 7.7 is equal to 0.50 by del t. That gives you the same value as 0.065. Okay. Moving on to the last three questions. Question number 5. Determine the time base setting. So guys, look here, we have the frequency. We know that frequency is equal to 1 by time period. So time period is equal to 1 divided by 5000. That gives you a value of 1 by 5000, which is 2 into 10 to the power 4 seconds. Now, time period, remember, you have to keep it in seconds. Time period is equal to time base times the number of boxes. In one period, essentially. So check this. How many centimeters do you have? How many 1 cm boxes do you have? This is the length of 1 cm. So you start from here, 1 cm, 2 cm, 3 cm, 4 centimeter. So 4 centimeter boxes. So can we write this? 2 in 10 power minus 4 is equal to time base times 4 1 centimeter boxes. So the time base is actually 2 into 10 power minus 4 divided by 4, which gives you a value of 5 into 10 to the power minus 5 second per centimeter. Okay, so that's 5 into 10 to the power minus 5 seconds per centimeter. Perfect. Now the intensity of the sound wave detected by the microphone is now increased from its initial value of I to a new value of 3I. The frequency of the sound is unchanged. Assume that the amplitude of the trace on the CRO scene is proportional to the amplitude of the sound wave. So since frequency is unchanged, the time period remains unchanged as well. We know that intensity is proportional to amplitude square. So I1 by A1 square is basically equal to the new intensity, which is 3 times I1 by the new amplitude whole square. So the new amplitude whole square is basically equal to 3I1 by I1 times A1 square, which is A square is equal to, we can get rid of this, 3 times A1 whole square. So the new amplitude is root 3A after root over, after we apply the root over to both sides. So what's the value of root 3? It's 1.73. Root 3 is 1.73. Now, they said that it was proportional to the intensity, or sorry, it was proportional to the amplitude of the original sound wave. What was the initial amplitude? It was 1 centimeter, right? So 1.73 times 1 centimeter gives you a value of 1.73. So essentially, your new wave should have an amplitude of 1.73 boxes over here. So that's 1 box, 1.2, 1.4, 1.6, 1.8. It should be in the middle to be 1.7, right? Basically, it should be in the middle. Similarly, 1.246, 1.7, minus 1.7, plus 1.7. Okay, so let's do this. We reach the peak over here, we reach the peak over here, and we reach the peak over here again. Okay, and these values will be the same, right? So let's do this. This is our new wave. Wait, bruh. Here you go. This is how you get full marks for that. Anyway, moving on to question number B. This is a double slit. Oh, yeah, it's a double slit. X equals to lambda d by n. Explain why the bright fringe is produced by the waves meeting at P. So what is P? P is the central maximum, right? So what happens in the central maximum? The path difference of the two waves is actually 0, because the line through P is essentially an equidistant line. Remember the perpendicular bisector? You learned this in O levels, Maths D. So yeah, the lines travel the same distance, so the path difference is 0, and as a result, there's constructive superposition. Okay, so that's our reasoning, that the path difference from the slits to P is 0. So phase difference. Oh, that was an alternate. You could say path difference or phase difference between waves at p is 0. This is optional, so constructive interference occurs. Okay, now let's find out d. So we know that x is equal to lambda d by a, or d is equal to ax by lambda. So d is equal to a, that's the separation of the slits, 3.6 times 10 to the power minus 4. What is x? X is the fringe width. What's the fringe width? This one, the distance between adjacent fringes, 4.0 into 10 power minus 3. And what about lambda? It's 630 nanometers, so that's 630 into 10 to the power minus 9. Let's do this. D is the distance between the slits and the screen. 3.6 times 10 to the power minus 4 times 4 into 10 to the power minus 3 divided by 630 into 10 to the power minus 9. That gives you a value of 2.3 rounded off meters to 2 SF, by the way. Okay, next one. The wavelength lambda of the light is now varied. This causes a variation in the distance x between the centers of the two adjacent bright fringes on the screen. The distance d and the separation of the two slits are unchanged. Okay, so x is equal to lambda d by a. We want to find out the variation between x and lambda given that the distance d and separation are unchanged. So these are unchanged, they're constants basically. So we can write x is equal to lambda into k, or x is proportional to lambda. So as we increase lambda, x will also increase. So it's a directly proportional relationship. So we should be getting a straight line. Okay. However, remember that it won't start from 0. X will not start from 0 because even at 400 nanometers, we do have a certain value of fringe width, right? So x will not start from 0. Okay. X would have started from 0 if the x-axis had a reading of 0 nanometer, but it's 400 nanometers. So we do have a certain value. However, it has to be a straight line, okay, which is increasing. All right. This indicates the proportional relationship between the two. So we have to draw an upward sloping straight line starting from a non-zero value at lambda 400 till 700 nanometers. Is that fine? This is why. Anyway, let's move on. Last two questions. Question number 6 and 7. We're gonna be done soon. Describe the potential difference across a component. Okay. So remember, potential difference is work done per unit charge or energy transferred per unit charge. Okay, they've accepted multiple answers in the mark scheme, as I can see. So we're just going to go with the initial one. It is the energy transferred from electrical to other forms. By charge or per unit charge. Okay, anything works. It's up to you guys. By charge. Now this is the IV characteristic of a semiconductor diode. Use figure 6.1 to describe qualitatively the resistance of the diode in the range of V0 to 0.25. So it's basically, since current is 0, it has infinite resistance because current is not flowing. So resistance is infinite or very high. Okay. Next, if the variation, if any, in the resistance of the diode as V changes from 0.75 to 1. From 0.75 to 1, as you can see from this point to this one, it actually, you know, what's happening to it. After 0.25, essentially, since current increases, so resistance is definitely decreasing, right? You guys know that. So you guys know that V is equal to IR and R is equal to V by I. So the gradient of the I by V graph is actually the reciprocal of R. Okay, so the variation, if any, in the resistance of the diode as V changes from 0.75 to 1 volts. So you guys might be wondering, okay, it looks like a straight line. But remember, in a diode, it's impossible that it's a straight line. It's actually curved, okay? It's going to be curved and it appears to go towards infinity. Okay, that's what happens, the gradient. So after 0.25 onwards, basically what happens? Resistance decreases as voltage increases. It's quite different from a filament lamp where resistance increases as voltage increases, okay? So our answer should be resistance decreases as voltage increases. So the graph was quite misleading, but constant was never an option, okay? Anyway, for part C, we have a battery of electromotive force 12 volts and negligible internal resistance. It is connected to a uniform resistance wire XY, a fixed resistor, and a variable resistor as shown in 6.2. So this variable resistor, right? It's over here, this rheostat. Now the fixed resistor has a resistance of 5 ohms. The current in the battery is 2.7 amps, and the current in the fixed resistor is 1.5 amperes. Okay, great. So since 1.5 amps are going here, so 2.7 minus 1.5, Kirchhoff's first law. So 1.2 amperes, that's the value going through XY. I just subtracted 2.7 minus 1.5 gives us 1.2. Calculate the current in the resistance for, oh, that's it. So current is equal to 2.7 minus 1.5 amperes, which is 1.2. Great. Determine the resistance of the variable resistor. Fine. So you guys have to understand something, that basically this is a parallel circuit. X and Y is in parallel with the two components down below. Yeah. So let's try to figure this out. The total EMF is 12, right? And there's no internal resistance. They mentioned that, so no loss volts. So 12 volts is the terminal PD. So let's find out the voltage of this guy over here. 5 times 1.5. That gives you a value of 7.5. So the net value should add up to 12. So what will the variable resistor get? 12 minus 7.5, which is a 4.5 volts. Okay, that's what we have to show. So Kirchhoff's second law, sum of EMF is equal to sum of the PD. 12 is equal to 1.5 times 5.0 plus the voltage of the variable resistor. So we need to find out the resistance of the variable resistor. So we can just write IR, right? 1.5 times the resistance of the variable resistor. So that gives us a value of 1.5. 12 equals to 1.5. 5.0 plus R. 12 by 1.5. 8. 8 is equal to 5 plus R. So R is actually equal to 3 ohms. Okay, that's good. Next. Wire XY is the length of 2 meters. So wire XY, the whole thing, will also get 12 volts. Now point Z on the wire is a distance of 1.6 meters from X. Okay. The fixed resistor is connected to the variable resistor at point W. They're connected over here. So maybe they're going to ask us to find the potential drop. Determine the potential difference between the points W and Z. Okay, exactly. So check this out. We started with a voltage of 12 volts on this side. Okay, so this guy over here is draining up 7.5. So what's the voltage remaining? 12 minus 7.5. We have 4.5 volts remaining over here. Okay. Now let's talk about the wire. How much is it taking up? We know that resistance is proportional to length, right? So can we do this? 1.6 divided by 2 times the total voltage. 1.6 by 2. That's the fraction that it's taking up of the total length times 12 gives you a value of 9.6. So this guy over here, this red part, is taking up 9.6 volts. Okay, so how much is left afterwards? 12 minus 9.6, that gives you a value of 2.4. So if you actually find out the potential drop between these points, it's basically going to be 4.5 minus 2.4, which is a value of 2.1. See if you guys understand. That's how you find out the potential drop. Okay, you have to find out the amount of voltage that this part is taking up on the left hand side, and then subtract from the total available voltage. All right, so let's do this. So the voltage of the xz part, voltage of xz is equal to 1.6 by 2.0 times 12, which is 9.6 volts. Okay, or we could just do it directly, we could just do 9.6 minus 7.5. That's also pretty fast, right? So what about this part, the voltage of xy, or the voltage that the resistor, 5 ohm resistor, is getting? So that's a xy, right? Wait, xw, my bad. Vxw is equal to 1.5 times 5 volts, which is 7.2 volts, 7.5 volts, sorry. So the potential difference is 9.6 minus 7.5, which is 2.1 volts. Okay, that's that. Or you could find out the voltage of this section, like 0.4 divided by 2 times 12, which is 2.4, right? The one I did over here, that was a more complicated process. Like, I already had these values, I could just subtract them to get the answer. Okay, so both ways work, honestly. Both are accepted in the mark scheme. Now the resistance of the variable resistor is now increased. Okay, now this guy showed up, so we increase the resistance of this component. Now you guys know something, that the component which has higher resistance will get more voltage. So clearly this value will now increase and this value will now decrease, because their net sum must be still equal to 12, but the rheostat will get more voltage while the fixed resistor will get less voltage. Now, that's not the question though. They didn't ask the change in the potential difference. They're basically asking us, by considering the currents in every part of the circuit, state and explain whether the total power produced by the battery decreases, increases, or stays the same. Okay, total power produced by the battery. What does this mean? Power produced by the battery is actually equal to P is equal to, that P is equal to IV. It's actually EI. P is equal to EI, where E is the EMF and I is the current. Okay, so the EMF is constant at 12 volts. So the power totally depends on I. So if I increases, power will increase, and vice versa. So let's see. So essentially, due to the increase in resistance in this section, the current over here, 1.5 amps, that's going to decrease. 1.5 amps is going to decrease. Okay, fine. Now, what about this section though? Now, section XY still has the same voltage of 12 volts because it's a parallel circuit. Okay, it still has 12 volts in total, and it still has the same resistance. So you know that V is equal to IR, right? I is equal to V by R. So voltage remains at 12, the resistance also remains the same, right? Because we bring about no change there. So the current remains the same at 1.2 amperes. So what happened, essentially 1.5 amperes decreased to something like 1.4 or 1.3, and 1.2 amperes remain the same. So if you add these two up, like 1.2 plus 1.3, you get a value of 2.5. So this value over here decreases to something like 2.5. Now the net current in the circuit decreases, so the power produced by the battery will also decrease. Okay, so this is how you write it. Current in the fixed resistor or variable resistor decreases. That's point number one. Okay, now the current in the resistance wire remains unchanged. I just explained why. So the net current in the circuit decreases. So current in battery decreases, and same EMF. So power produced by the battery decreases. Is that fine? Okay. Hopefully I could clarify. Moving on to the last question. Nuclei X and Y are different isotopes of the same element. Nucleus X is unstable and emits a beta particle, beta plus particle. Okay, so this is beta plus decay to form nucleus Z. By comparing the number of protons in each nucleus, can I explain whether the charge of nucleus X is less than, the same, or greater than that of the charge of nucleus Y and nucleus Z? Okay, so they're different isotopes of the same element. So basically, remember, if you're isotopes of the same element, you have the same proton number but different mass number. Okay. For example, let's consider that X is carbon 12, so it might be 612, while Y is something like carbon 13, which is 613. Okay, I'm just using an example. Same proton number, different mass number. Now, what happened was, basically, um, it decays to form a beta plus particle. Okay, so let's make, wait, let's do this. Why don't I make Y carbon 12, right? This makes sense. And X is carbon 14. Now this is fine. Okay. So X decays to form a beta plus particle which has a mass of 0 and a charge of +1. So the new nucleus that forms is Z. We also release an electron neutrino, and the new nucleus will have the same mass, right? However, the proton number decreases by 1. Why? Because we need to maintain charge. So let's compare things now. By comparing the number of protons in each nucleus, state and explain whether the charge of nucleus X is less than, the same as, or greater than the charge of nucleus Y. So X has a charge of +6. So compared to Z, it has greater charge, right? Compared to Z, it has greater charge. And compared to Y, it basically still has the same number, right? So X has the same number of protons as Y. And so charge of X is the same as charge of Y. Okay, that's fine, pretty easy. Now X has one more proton than Z, right? So X has greater charge than Z. Okay, so we had to say if it was less than, same, or greater. I opted for same in the first one and greater in the second one. Yeah. Moving on to the next one. Hadrons can be divided into two groups. You know that hadrons have two families, right? We have mesons and baryons. State the name of group Q. Group P is baryons, so group Q must be mesons. Describe in general terms the quark structure of hadrons that belong to group Q. So basically, remember, a baryon is made up of three quarks. They can be any combination of quarks and antiquarks. But a meson is made of one quark and one antiquark. Remember that. So it has one quark fixed, right? And one antiquark. That is all, guys. Overall, I think it was a pretty easy paper, except this one mark over here, the one with, the statement about whether it increases or decreases. That was a bit tricky. And overall, it was pretty easy. There was just a few things that you had to keep in mind, like this non-zero value, and in electricity, this theory over here, it was a bit difficult. But yeah, it was much more easier than ON22, where 2122223 specifically. Okay. So hope you guys like the video. I'm gonna link the paper for February March 2022, paper 2 up here, and the paper for October November 2022, paper 2 down here, and the playlist for physics paper 2 up here. And remember to hit the subscribe button. See you guys.